We're going to look at another kind of expression. This one is referred to as a Boolean expression. Remember that we previously talked about expressions and in particular what we call arithmetic expressions. Arithmetic expressions are composed of operators and operands where the operators tend to be the arithmetic operators like addition, subtraction, multiplication, and the operands are usually integers or floating point numbers. In the case of a Boolean expression, we still have the combination of operators and operands, but the resulting values are a little bit different. And in this particular situation, we introduce a new data type that we've not seen before, and this data type in Python is called bool. The Boolean data type in Python is similar to the data type int or the data type float in that it describes a collection of values. The difference is that the data type bool is much smaller than the int or the floats. There are really only two values in the data type bool, and the values are, quite simply, true or false. We represent those as simply the identifiers or the keywords capital T, RUE, and capital FALSE. It's very important to realize that these are capitalized. So when we are working in the Python code window and I want to think about the value of true or the value of false, just like I can say let's print the value 45 or let's print the value 34.7, I can also say what happens if we print the value true, or what if we print the value false. Because these are the literal values of the Boolean data type, the bool type, when I run this, you can see when I print 45, I get 45. When I print 34.7, I get that value. And now you can see when I print true or when I print false, I see those values show up as the result. It's also interesting to note that I can use my type function. So for example, I can say let's print the type of true. And if I do that, I'll see that the result is class bool. True comes from the data type called bool. On the other hand, it's very easy to make the mistake of thinking that these are strings. But notice that if I print the type of quote, TRUE quote, that is a string value. It's a very different value. When I quote a string, I'm referring to the value that corresponds to a sequence of characters, TRUE. When I use the word true, it's an atomic value, just like the value 34. I can't decompose it. It's made up of a single autonomous unit, and true and false work the same way. So then the question becomes, what do we typically do with these values from the data type bool? And the answer is that we oftentimes will use them because they are the results of other expression evaluation, in particular these things called Boolean expressions. So a Boolean expression is a combination of operators and operands that returns or evaluates to a Boolean data value. And the easiest way to create a Boolean expression is to just think about the fact that a variable that refers to a Boolean will be evaluated and it returns a Boolean. So for example, if I say stop is assigned to the value false, and then I say print the value of stop, we would expect that when I run this program, it's going to print out whatever stop refers to, because stop is assigned to, it's assigned to refer to the data object false, when I print the value of stop, I see that it shows false. If we look at a reference diagram for this, it's going to be as we would expect. The variable stop is going to be a reference to a data object, but that data object is now going to be the data object false. When I evaluate stop, I get the value that stop refers to. Because it's a Boolean, we could say that the evaluation of the variable stop is an example of a Boolean expression. But of course, there are other ways that we can write Boolean expressions that might be more familiar to us. And in particular, we can use what are referred to as the relational operators. And you've seen these probably before in a math class. We can talk about something being less than, or something being greater than another value, or we can talk about less than or equal, or greater than or equal, or we can talk about two things being equal or two things being not equal. If you think about it, if I ask the question, is one item greater than another item, the result is true or false. And so these relational operators are used to produce what we would think of as being relational expressions, and those relational expressions are just a special kind of Boolean expression. It's important to look here and notice that these operators are consisting of more than one character. So for example, the equal operator is something equal to something else is actually composed of two equal symbols, but there's no space in between. So when I use this symbol, which consists of two characters, it's referring to the concept of equality. And the reason I can't use the single equal character is because I already used that for the assignment token. Likewise, for less than or equal or greater than or equal, we can't use something like this, which we might see in math class, because there is no character like this on the keyboard. So we have to use something that might be available. We use two character keystrokes, no spaces, to represent the concept of less than or equal or greater than or equal. So how can we look at examples of these kinds of Boolean expressions? Well, let's say that I would like to ask the question, is 3 less than 4? And I want to print the result of asking that relationship. Well, we know that 3 less than 4, that's a true relationship, and so the result of that relationship expression, the result of that relational operator working on 3 and 4 is going to be true, and so this should print out the value true. Of course, it's also going to print the value false because I've left this here. So now we see that false because stop is equal to false, but now 3 less than 4 is true, and so the result true shows up. I can take this one step further, and I can think about using variables. So for example, let's say that I had a variable called total, which is currently assigned to be 0. I could ask the question, is total equal to 0? And as we would expect, when I run this, I get true, because currently total is referring to 0. If I were to ask, is total not equal to 0, now when I run this, I'm going to get false, because total is 0. 0 not equal to 0 is false, and so the print shows me that result. So we can use these simple comparison operators with any sorts of operands, either simple variables or constants, or we could actually have other arithmetic expressions, and then we evaluate those expressions and compare them according to that relationship. It's very important to remember that when you want to compare for equality, you need to use the double equal and not the single equal. The single equal is for assignment. Now, it turns out that there's another set of operators that come into play when we're talking about Boolean expressions, and these are the so-called the so-called logical operators. And the logical operators are and, or, not. These operators actually work with operands that are Boolean data values. And so if we want to understand how they work, we can look at how they execute or how they evaluate when we run simple programs. So for example, if I say print the result of true ANDed with true. As I said before, the AND operator takes two Boolean values and processes them. And the way that the AND operator works is that it returns a true if both of its operands are true. So if one and the other of its operands are true, the result will be true. So if we run this, we see that the result is true. True and true gives me a true. On the other hand, if one of these had been false, true and false, well, they both need to be true for the result to be true. So now when I run it, we see that the result happens to be false. One thing that we can do to see the logical operators in action is to compare or to combine them with the relationship operators. And so, for example, if we go back to a previous case where we had a variable called total that we had assigned to be 0, I could create a Boolean expression that might look like this. Total equal to 0 and 3 less than 4. Now what this says is, I want to ask the question, is total equal to 0? That's either true or false. And then I want to ask, is 3 less than 4? That's either going to be true or false. Well, it turns out total is equal to 0, so this is true. 3 less than 4 is 0, so that's true. Two trues ANDed together is true, and the result is true. Had I asked the question, total equal to 0 and 3 greater than 4, now 3 greater than 4 is false. True ANDed with false. Well, if they're both not true, then the result is going to end up to be false. And the same thing happens when we talk about OR. If I were to look at this same expression but use an OR, the OR says if one or the other is true, the result is true. So in this case, total is equal to 0, but 3 is not greater than 4, but that's okay, because as long as total is equal to 0, one of these is true, therefore the result will be true, and we see that when we run this, we get a true value. Even though 3 greater than 4 is false, total equal to 0 happens to be true. And the last example, the last operator would be not, and you probably can think about what that means. Not will return the opposite. So if something is false, not will return true, and if something is true, not will return false. So if I say not total equal to 0, total is 0, total equals 0 is true, but when I take not true, I'm going to then get the value false. So these operators and operands work as you would expect, but it's important to point out that we now have a situation where we have a number of different operators at work. We've got our arithmetic operators for multiplication and division. We've got our addition-subtraction operators. We've got our relationship operators. We've got our Boolean logic operators. And of course, there has to be a precedence here. But if you look at this last example, you can see that the relationship operator was done before the logical operator occurred. And in fact, that's what we would expect most of the time, that we would want to take the negation of a relationship, or we'd want to take the and or the or of the result of a relationship. And so the precedence works that way. The relationship operators have a higher precedence than the logical operators. but the arithmetic operators are going to have a higher precedence than all of them. So if you look at the precedence table, what you will discover is that the operators turn out to be ordered in such a way that the arithmetic happens first, the relationships happen second, and then the logical operators happen third. And that fits very nicely into the way we typically use them. Of course, if you want to, you can always use parentheses to force the precedence.